are going to analyze the principle of action and reaction. Action and reaction, they are not very good words, I think. It will say that because it say that there is first the action and later the reaction, and it's not true. What does the third law of Newton say, that is named as the law of action and reaction? It says that for every interaction that an object is doing on the second one is doing the same interaction, the same force on the object too. So for every action on a second object produced by the first, of course, there is a reaction. There is a force, and this force is opposite with the same magnitude, but is applied to the first object. For example, imagine the girl and the boy. Imagine they have a force of interaction that is a repulsive interaction. So the force acting on object 2 due to 1 is going to the right. So what it means is, it means that no way the force acting on 1 due to 2, the force acting on 1 due to 2 have to go to the left. And the magnitude of this force is the same magnitude as this other force. So the equation that we will write is that F acting on 1 due to 2 is the same amount of force acting on 2 due to 1, but in the opposite direction. Okay. This force doesn't have to be repulsive, it can be attraction. So in this case, the equation that will take place is the same equation. In this case, the force acting on 1 due to 2 is to the right. So what it means is, it means that necessarily, according to the third law of Newton, the force acting on 2 due to 1, the 1 object 2, the 2 is going to the left. So this is the fundamental thing of the third law. It's important to realize that the force acting on 1 is on 1, and the force acting on 2 is on 2. Okay, so they are not the same force applied to the same body. They are being applied to different bodies. It's true also that F12 plus F21, the force acting on 1 due to 2 plus the force acting on 2 due to is 0. This comes from this relation. Also, you can see here that this force of the same magnitude as this force, the sum of the two forces will be 0. But what it means this exactly is that if you put the two objects together and you consider the system made by the two objects, these forces will be internal forces. And the sum of the two internal forces will be 0. So these two forces, that the sum is 0, cannot accelerate the two bodies. Oh, so it means that no one can accelerate? Yes. But the sum of the forces acting on the two bodies produce a net acceleration on the two bodies that is 0. We will see this idea with the concept of center of mass, how the center of mass, indeed, what we are saying is that there is a point in the middle of the two, that is the center of mass, and this point, the center of mass, will not accelerate to the right, will not accelerate to the left due to internal force. So, in some way, your body, if you imagine your body like this, and you imagine your body made of two pieces, and you don't have the floor. You don't have the floor here to this is N1 and this is your legs is N2. And you are here in the air. Let's say there is no any other forces. And you can, if you produce a force, if the mass N2 produce a force of N1, N1 will receive a force in this direction, and N2 will receive a force in this other direction, but the center of mass of your body will not accelerate because the total force is zero. We will see this with more detail. Let's go to visualize more the 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 third law of Newton. So this is the force on the bear due to the car. It's going in this direction. This is the force on the car due to the bear. It's going in the opposite direction. What is this magnitude? This magnitude, the length, is the same length that here. This is what it says Newton's law. If you have a collision between the car and this big bear, let's say small car and big bear, the forces acting, one will be in this direction, the other one will be in the opposite direction. If you make the bear very small and the car very big, the forces will not change. This force will be in this direction, and this other force will be in the same direction. Let me picture the force will be the same one with the same magnitude, this one. It doesn't depend, the force doesn't depend of the mass of the object, the force acting on the bear due to the car, the one, is the same force acting on the one on the car due to the bear. The bear. Yeah, different directions. Okay, the same magnitude, different direction. So F acting on the bear due to the car is always equal in magnitude and different direction. This is the minus sign, different direction, as the force acting on the car due to the bear. So this is the idea that is in Newton's law. You must trust Newton's law. We test Newton's law in many experiments, and this is the idea. Now, let's go. Let's go to visualize the action and the reaction. Okay, this is a boat in a surface that is the water. Let's say that there is no friction here between the water and the boat. So the man, the guy that is here, is making a force on the boat to the right. So because he's making a force on the boat to the right, it exists a force on the man to the left. And this is what it allowed to the guy to jump to the water, of course. So for every action, there is a reaction, opposite, and the same magnitude. Let's go to do this case, for example. This is the book. The book is on the table. So the weight of the books is the force that the earth is doing on the book. The reaction is not the normal force. The reaction to this force is on the earth. The reaction is here. This is the earth, and this is the force. The same amount of force is acting on the earth. Okay, um, this normal force is the force that the table is doing on the book. So what is the reaction? The reaction is the force that the book is doing on the table. Same magnitude, normal reaction. The reaction is going in on the table. So it's different thing. Okay, to do more example. This is a gun, for example. So there is an explosion inside, and the explosion makes the gun suddenly to move in the direction, accelerate to the right. So there is a force to the right of the bullet. So it means that there is a force on the gun to the left. So this is the recoil force of the gun. Okay. When you walk, how you can walk? Okay, your foot, well, indeed it push down and back, but let's say that push back. So you make a force on the floor. This is the floor. You make a force on the floor to the left. So on you, there is a force to the right. And this is what will allow you to walk. The friction force will allow you to walk because you make a force to the left. Okay, you make a force to the left. And there is another force acting on you to the right. And this is the force acting on you to the right. And this force is the friction force that is pulling you forward. Okay, let's read more examples. Suppose you are in a pool, so you are doing this. This is the force that you do on the wall. So the wall will do a force on you to the left. So you can swim, you can advance in this direction. And of course the wall will accelerate in the right direction. You don't see the wall accelerating to the right direction because the wall have another force. The wall is tied to the earth, and here is another force that is sustaining the wall. So this is another examples. Let's say that you put your finger on a wall. So you make a force, your finger make a force on the wall, and this is the force acting on the wall. And the wall is doing a force on you, and this is the force acting on your finger by the wall. Okay. How a rocket or a plane flies. This is the force done to the gas in this direction, going downwards. So because there is a force that the engine does on the molecules of the gas going downwards, now on you, this is the force that the rocket do on the gas. So it's going downwards. And the force that the gas of molecules that are moving with certain velocity is doing on you is the reaction. So this force will accelerate the rocket up. Okay. If you, for example, if you boxing, if you are boxing, this is the force acting on the guy, on this guy that is receiving the the, the strong heat. This is the force acting on the guy. And this is the force that the guy is doing on the feet. So you can break your feet. Of course that you can break your feet. And of course you can break the jaw of the guy also. So this is how it works. This is even more interesting. Imagine this is the object. The object will be by the gravitational force. The gravitational force will do like this. There is a tension here, there is a tension, and there is the weight mg. And the sum of all the forces, the sum of the tension and the mg will produce a force, the sum will produce a force in this direction. And the force in this direction will make a change in the velocity of this ball. So the ball will move in this direction. So when the ball is moving in this direction, it will make a force on the ball E due to F. So there is a force on E due to F to the right. And what will happen to the ball F? The ball F will receive a force going to the left on the ball F. This is the reaction. So the ball F will do like this, will go like this, and will go back because it will receive a force going in this direction. This is the reaction. So in the first step, it will go to the right due to this force. Due to this force, it will accelerate to the right. So it will have a collision with E, with the mass E, and the mass E will produce a force on the mass F to the left, acting to the left, and the mass E will receive a force from the F to the right. Interesting. So the principle of action and reaction is quite important to realize how it works. So here, this is the weight, and the weight is going here, and the reaction is this one, And this R is the force that the surface of the earth is doing on the guy. And this force is the force that the guy is doing on the surface of the earth. Okay, so more action and reaction. You can imagine here what is happening. So we are going to apply Newton's law to this problem. So we are going to solve this problem. Let's say that you have two bodies of mass m, 2 kilograms and mass 4 kilograms, and you apply a force of 6 newtons to the body of 2 kilograms. So the problem say, first, what is the acceleration of the two bodies? So the total force is going to the right. So the two bodies will remain together and will have acceleration. What is the total acceleration? So I will apply Newton's law. Newton's law says that the sum of all the forces equal the mass by the acceleration in vector form. What is the sum of all the forces? The sum of all the forces is 6 in the x direction. So I will take plus 6 I will call it. So equal m, the mass. What is the mass? The mass is 2 plus 4 by the acceleration. So the acceleration of the system of 2 and 4 kilograms will be A equals 6 divided by 6. So it will be 1 meter per second square. So we know now that both of the body, they are moving at 1 meter per second square. So A is 1 meter per second square, and A is 1 meter per second square. Now the question is, what is the force that the object of 2 kilograms is doing on the object of 4 kilograms? So this is being solved by using the principle of action and reaction. So we will solve it. Let's go to apply. We first we isolate the object. Every object, we have two objects to isolate. The first object is the 2 kilogram. So the 2 kilogram will receive a force of 6 newtons to the right, an unknown force due to the 4 kilogram to the left. Let's go to call this force the force of the body 2. Let's say that this is the object 2 and this is the object 1. This is the force acting on 1 due to 2. And it's unknown, but I know that the acceleration A is 1 meter per second squared. So I will apply Newton's law and I will say, what is the sum of all the forces? Well, the sum of all the forces is the mass by the acceleration. In this case, in the x direction, how much forces do I have? I have the 6 positive going to the right minus F12. And this is equal the mass 2 by the acceleration 1. So 6 minus 2 by 1 is F12. So F12, the force acting on 1 due to 2, is a force of 4 kilograms. And this force is going, has the magnitude 4 kilograms, but it's going to the left. Oh, how do I know that it's going to the left? Should be going to the left because see, 6 minus 4 is 2. So this for F12 is going to the left and have the magnitude 4 newtons, sorry. 4 newtons, okay. So what is F acting on 2 due to 1? F acting on 2 due to 1 should be how much? 4 newtons also. But this is going to the right now. Okay. So let's go if everything is being coherent. Now I have the object of 4 kilograms. What is the force acting on the object of 4 kilograms? Well, the force F21, the force acting on 2 due to 1. So we'll apply Newton's law. The sum of all the forces is the mass by the acceleration. The sum of all the forces is 4 going to the right, equal the mass 4. And the acceleration should be 1 because 4 by 1 should be 1. So it's correct what I'm doing. So F21 equal 4, magnitude of F21 is equal 4 going to the right. This is the problem, and this is the solution. Let's say what is the force, what is the 6 newtons applied to the, what is the force acting on the object of 4 kilograms? The force acting on the object of 4 kilograms is 4 newtons to the right. Okay. Now we are going to start a very important subject, that is conservation of momentum. Momentum, if you remember, is a vector P, we call P momentum, and it's the mass of the object by the vector velocity. This is the momentum of an object. If an object has mass 3 kilograms and is moving in the direction x with 3 meters per second, the momentum P will be his mass, 3 kilograms, let's say, and his velocity, let's say 2 meters per second, 2i. So his momentum will be 6i. 6 what? 6 kilogram meters per second. So momentum is a vector. So we are going to introduce to relate the principle of action and reaction and the momentum. You know that F12 is equal minus F21. F12 is the force acting on 1, so it's the mass 1 by the acceleration 1. F21 is the force acting on 2, so it's the mass 2 by the acceleration 2. So the relation that say the principle of action and reaction is that M1 by A1 is equal to M2 by A2. And A2 is a vector. is a vector. So, A1, what is A1? A1 is the change in the velocity V1 final minus V1 initial divided by delta t equal minus M2 by A2. What is A2? V2 final minus V2 initial divided by delta t. So delta t will disappear, and now the equation will remain like this. So if you order the equation a little bit, you reorder, you will find this equation. You will find that N1 B1 final plus N2 V2 final equal N1 V1 initial plus N2 V2 initial. So in terms of momentum, we'll say the initial momentum of the particle 1 plus the initial momentum of the particle 2 as a vectors, two vectors. The sum of these two vectors is equal to the sum of the final momentum of the particle 2, P2 final, plus the final momentum of the particle 1, P1 final. So this is a final. Okay, if you reorder the equation, you will find this. So what it says is that the Pi is equal PF. The momentum doesn't change. The total momentum is P initial P1 plus P2. So the P final, this equation say that the P capital P final is equal in vector form a capital P initial if there is no external forces acting on 1 and 2. This is true if this is happening. So because we start with only these two forces, force acting on 1 and 2, so we assume that there is no other forces acting on 1 and 2, only interaction between them. So interaction between two particles produce what we call the conservation of linear momentum. And the conservation of linear momentum say that the whole initial momentum, Pi, is equal to the whole initial momentum, Pf. So in one V1 initial vector plus M2 V2 initial, the second particle initial equal M1 V1 final plus M2 V2 final. And this is a vector, this is a vector, this is the sum, and this is a vector, this is a vector, and this is the sum. So what it says, Pi equal Pf. Total momentum initial equal total momentum final if the sum of all the external forces are zero. Okay, this we will use later on chapter 8, but you need to visualize this, to start visualizing this. I want you to visualize things in a different way. F12, the force acting on 1 due to 2 is the change in the momentum of 1 per unit of time, while F21 is the change in the momentum of the second particle per unit of time. And what it say, the third law of Newton, the action and reaction, it say that F12 is equal minus F21. So what it says is that the change in P1 equal minus the change in P2. Now I want to see the same principle of conservation of momentum. This is the principle of conservation of momentum. If you develop this and you put it P1 final, the change in momentum is P1 final minus P1 initial equal minus P2 final minus P2 initial, you will obtain the same principle of conservation of momentum if you reorder. But I want you to see this in terms of the change. So imagine this is a particle P1i. Imagine that you see the particle with this momentum. It means that the velocity is in this direction now. The mass doesn't change. Let's say that the mass has not changed. So the object of mass m was moving with velocity v1i, v1 initial, in this direction. Later on, he was moving in this direction. So what you would say, something is acting. What is acting? The force, the change in momentum, the change in P1 is the force acting on 1, of course due to 2, by delta T. So this is the change in momentum. So this change in momentum is F1 by delta T. Now what happened with P2? Because the change in P1 goes from the head of P1 initial to the head of P2 or P1 final. So what happened with P2? Imagine that P2 is moving like this. So the change in P2 is the same change that P1 has done, this change, but in the opposite direction. This is what it says in this equation. So P2 plus the change in P2, it will be P2 final. So if you start a problem with P1 going to the right and P2 going like this, and delta P1 is going to here, so P2, it will go in this direction. P2 final will end in this direction. So let's say, for example, that P1 is going in this direction, P1 initial is like this, P1 final is like this, and delta P1 is like this. But let's say that now P2 is in this direction. So if P2 is coming in this direction and have a collision with the object 1, the change in P2 is the same change that has in P1 but opposite. So now P2 final will be P2 plus the change, P2 final. So P2 final will move in this direction, while before was moving in this direction in this case. So you can get conclusion about this and think about this a little bit. So let's go now to frictions. Friction forces are forces that exist. The magnitude of the friction force, this is wrong, okay. The magnitude of the friction force is proportional to the magnitude of the normal force. Why I say that this is wrong? Because the friction force is going in some direction that is opposite to the vector velocity. So if the object is moving like this, the friction force is going in the opposite direction. This is the friction force. Okay, so I cannot write the equation F equal mu by friction force equal mu by N because N is going upwards and the friction force is not going upwards by some coefficient mu. So mu is what we call the coefficient of friction coefficient is something that is between 0 and 1 and depends on the surface on contacts. So the relation that you will use is that the friction force depends on the normal. What it means this? It means that if the normal is very big, the friction force is very big. And when the normal will be big? Well, in normal circumstances, if you place a massive object, will be a big weight. And because it will be a big weight on the table will do a normal force that it will be big. So the friction force will be bigger and it will cost you more to move the object because there will be a friction force on here. So a friction force that will be bigger because so we'll see friction forces in my notes. Please see my notes and we will see more complete things about friction force. But I want to touch the subject because how we walk. We walk because there is friction force. Otherwise, we cannot walk. This is me or you. This is the floor. The only way that I had my feet to make a force on the floor if there is a friction force. If there is no friction force, I cannot make a force on the floor. Then the force cannot be on me. It's a principle of action and reaction. So we can walk thanks to the friction force. How a car can move? A car can accelerate. A car can accelerate because there is a friction force acting on the car that have to go in this direction, the friction force. If you want to produce an acceleration, an acceleration in this direction. So if this is the force that is acting, the car is acting on the floor with this force. And the floor is acting on the car with this friction force. And this friction force is the one that makes possible to the object to accelerate, to change its velocity, to start moving. How can a car can stop? Well, you think about it. You think how a car can stop. It's because there is also friction force. To where it will go, the friction force? Hmm. Okay, I'll leave you this question for you. Acceleration in if you want to produce. Now I want to talk about these two terms. Rolling with no slippery. Rolling with no slippery, it means imagine a tire, the tire of your car. So rolling, what is the condition of the tire? The tire is rolling and is moving in this direction. The tire is as angular velocity. The direction of every point of the tire it will be velocity is a circular motion. Okay, this point will move with velocity v respect to this guy. So what it means no slippery? No slippery means that when the tire goes one revolution, he will advance 2 pi r. So this is the radius r. So it means that when the tire moves one revolution, the wheel will advance the distance 2 pi r. And what it means rolling with a slippery. Rolling with a slippery means that the tire will move, but will not be able to advance the 2 pi r when he does one revolution. And this is rolling, so if he doesn't arrive to the 2 pi r after one revolution, this is rolling with a slippery. You see some guys trying to roll the car, rolling the tires with a slippery, just playing, I don't know what they play, but they do it. They do. And of course, they produce a big deterioration of the tire, of course, because there is friction force there. So there is friction force here, is a static friction, and the tire is moving in this 2 pi r. When he goes one revolution, no slippery. And with a slippery, less than 2 pi r. That's all.